The distance formula can be a useful tool in finding the distance between 2 points on a coordinate plane. Let's first cover a few basic concepts. One that we need to talk about is slope. When we find the slope, we need to find the rise and the run between 2 points. And we always look at these points from left to right, so the leftmost point to the rightmost point. For example, these 2 points are located at -1, 3 and 4, 2. To find the slope between these points, we would need to figure that the rise goes down 1 unit and the run goes across, let's see, 1, 2, 3, 4, 5 units. And so my rise to run ratio becomes down 1 and across 5. So represented in a fraction, the slope is -1/5. One way to figure this out using the numbers just from the ordered pairs here is to take my x and y values and subtract them, this time going in reverse to find out where did I come from. So 4, 2 got there by following the slope -1/5 from -1, 3, and that can be found by this concept right here. So this is the first ordered pair, the -1, 3, and we'll call that x1, y1, because that's its x and y values. The x value is -1, the y value is 3. The other ordered pair we'll call the second ordered pair, so it's x2, y2. So x2 is 4 and y2 is 2. And in order to find the rise, which was -1, we could take the y values, since the y values is what talks about the up and downness of the problem, and take the 2 and subtract where we came from, which was the 3. This concept is used quite frequently in physics and engineering. It's probably more simply put as final minus initial. So final was the 2, that's where we ended up. Initial was the 3, that's where we started from. So 2 minus 3 is the numerator of my slope. The denominator can be found by doing the same thing just with the x coordinates. So where did I end up? At the 4. Where did I start from? At the -1. And so we'll subtract -1. When we subtract a negative, we get a positive value. So the numerator becomes -1. The denominator is going to be really 4 plus +1, which is 5, which gives us the same slope that we had found earlier by counting it on the coordinate plane. Now, you're wondering, what does slope have to do with distance formula? Well, we're getting there. Let's keep in mind from this problem that the rise was -1, represented in blue, and the run was 5, represented in green. These numbers can be useful when I'm trying to actually find the distance between the two red dots. That distance can be found using the Pythagorean theorem and making a right triangle for the legs of which I've already drawn in green and blue. So let's find that now using the Pythagorean theorem. My side lengths are listed here as 1 and 5. The rise was -1 because the negative indicates a direction that we went. The 1, the positive 1, representing the leg of the triangle, is a distance and cannot be a negative value. It actually doesn't matter if it's a negative value, so long as when I square it in the Pythagorean theorem, I'd be sure to include the negative in what I'm squaring. So -1 times -1 will equal the same thing as +1 times +1, which I'll show you in just a second. So we start out with a squared plus b squared equals c squared, which is just the Pythagorean theorem. We substitute. I could substitute a -1 here for a, and it wouldn't make a difference. If it was +1, I would still get 1 in the next step. So that didn't really matter. B becomes 5 then, I guess, and then c squared is unknown. So I get 1 plus 25 equals c squared. So 26 equals c squared. If I square root both sides, I get that c is the square root of 26. That is using the Pythagorean theorem to find the distance between those two red dots. Now, how does the distance formula come out of all of this? Well, the distance formula is a way to just use the coordinates to find those distances instead of having to draw a triangle, because you may not always have a coordinate plane handy to be able to draw the triangle on. Or the distances on the coordinate plane might be really big distances and they're uncountable, or maybe they're decimals, and so it's like really hard to approximate with your eyeball how far it is from one to the next. To derive the distance formula, let's start out with the Pythagorean theorem and solve it for c. Right now it looks like it's solved for c, but it's got a squared on the c. We need to get rid of that. This can easily be done by just square rooting both sides. So the square root of c squared is just c, and the left side, which is going to become the right side of my equation, is just the square root of a squared plus b squared together. So all of that is the radicand. And that's solving for c. That is the hypotenuse of any right triangle. Why don't we list the Pythagorean theorem this way? Well, probably because it's easier to say it as a squared plus b squared equals c squared. But let's back up to my problem that had those coordinates and see if we can figure out what a and b are in terms of those coordinates. So I've backed up a screen, and here we can see that my blue distance is 1, and that's one of the legs. That would represent, I guess it represented a when I solved for it using the Pythagorean theorem. How do we come about that number, though, or even the negative one? Like I said, it doesn't matter if I use a negative value, because when I square it, that negative will go away. How do we come about that from the ordered pairs that we were talking about when we were first talking about rise and run? Well, the negative 1 came from the y2 minus y1, which helped us to find what the rise was. So y2 minus y1 is the rise, and that gave us one of our legs. Now let's go back. Here's my formula solved for c, and I've got my a squared plus b squared inside the radical. A squared we just found out was y2 minus y1. Let's replace it with that, like so. This shows that y2 minus y1 squared is the same thing as a squared. I'm going to do the same thing with b squared here in just a second once I figure out how to calculate the run. Let's go back to the other screen for just a second. The run again was figured out from x2 minus x1, and that gave us this 5. Okay, so x2 minus x1 tells me what the distance for the other leg is. Going back, this means that b can be replaced with x2 minus x1 in this equation. I've noticed a mistake here, so I'm going to try and fix some things really quick. Just a sec. Here's the equation for the distance formula written out using the coordinates instead of the lengths of the legs. So the blue stuff really just represents the length of one leg, which is the rise. The green stuff just represents the length of the other leg, which is the run. When you end up plugging in the values from the ordered pairs, you're going to get the exact same value. Let me show you. Here are my ordered pairs again, and we're going to remember that we went from the left to the right, so we started here and we ended here. And so this one represents the first ordered pair, and this one represents the second ordered pair. Does that make a difference? Yeah, only for keeping it straight. If I use one of the ordered pairs for y2, I have to use its same x coordinate for x2. I can't confuse those or I'll get my answer all messed up. Anyway, so final becomes the second one, and then I'm going to plug in my 2 for y2, and I'm going to plug in my 4 for x2. Then I'm also going to replace the y1 and x1 values with my 3 and my negative 1. Be sure to put in the minus sign from the equation. Let's put in all parentheses or plus signs or squareds, all of that. This then is going to tell me what c is equal to. Let's simplify it. Oh, I forgot a minus sign there. So c should be equal to the square root of 2 minus 3 is negative 1. We'll square that. Plus 4 minus negative 1 again is 5, and we'll square that. So this is going to give me the square root of negative 1 squared is 1, plus 5 squared is 25, and I'm running out of space here, but we end up with the square root of 26, just like we did on the previous screen. This lesson has gone kind of long. I apologize for that. It's over 10 minutes, but here are your two problems that are your practice that we're going to see show up on the warm-ups tomorrow. Okay, good luck.